Hi, I'm Creston, and in this tutorial we're going to cover PostgreSQL streaming replication. We're going to go over a few slides that explain some concepts, and then we'll jump into the command line to set up database replication. All right, let's get started with PostgreSQL streaming replication. So in terms of replication in general, I'm talking about physical replication, where your entire database cluster is replicated to another server, typically called a replica. It does this by using the WAL files to stay in sync. That is, those are the write-ahead logs. So those are constantly produced on a master that's in archive log mode, and those can essentially be transferred to a replica to be replayed to keep up to date and in sync with a master. Now, it replicates everything in the cluster, so you cannot replicate only certain databases or tables or data. If you're looking to do that, that would be essentially logical replication as opposed to physical replication. Replicas can allow reading of data and act as a hot standby to replace the master. So these can be up and ready to jump in the master's place in case of a failure, and you can also have it so that you can do selects from those replicas. A replication can be synchronous. By default, it is asynchronous, meaning a change is committed on the master, it's written to the write-ahead log and streamed to the replica, and then it's updated and committed there. However, you can make it be synchronous so that before a change is committed, it needs to have been updated on one or more replicas. However, there are some caveats with this, and you want to have a very good network connection between and have them in close proximity when doing synchronous replication to it. Otherwise, if it can't contact the replicas, your master database cannot commit transactions. In addition, replication can also cascade, so you can essentially have tiers of replication. So a master can synchronize to, say, a first tier replica, and then another tier of replicas can sync from those tier 1 replicas. Now, you'll hear the terminology log shipping and streaming. Log shipping is essentially taking the WAL files and transferring them to the replica to be replayed. So that is an option, or you can also stream it. That is where the replicas connect to the master, or if you're cascading, another replica, and it streams those changes over the network to be able to update the database and keep them in sync that way. That is streaming. And then as a caveat, all replicas must use the same major version. So be sure to keep that in mind when you're using physical replication. All right, let's jump into the live examples. Okay, I am using Ubuntu for this example, and I have already installed Postgres version 10, which is the latest version as of this video. And the first thing we're going to do, I'm going to use this Ubuntu specific command where it essentially just lists the clusters that are available in the system. So pgls clusters. So by default, when you install Postgres 10 on Ubuntu, it's going to create a cluster called main. You can see it's version 10, and it's at this default port. This is important because the replica I'm going to be setting up is going to be on the same machine, and it will be on a different port and with a different cluster name. But by default, this is where the Ubuntu installer places the data directory, the log files, and the configuration files are in a similar path for /etc/PostgreSQL. All right, so we want to create a replica cluster. So again, I'm going to be using this Ubuntu specific command. On other distributions, there are other commands you can use. So I'm going to create a version 10 replica cluster. Okay, so that has been created. It has not been started. You can see the status is down. And just to confirm that, you can use pgctl cluster just to look at the status, and it says no server is running there. You can also use the systemd commands to check the status as well. So the main cluster is running, and I can also check the replica, and we can see that is inactive or dead. Okay, so as the next step, I want to create a separate archive directory where the WAL files are going to be produced for each of these clusters, for both the main and replica. So I'm going to put it, this is the base of the Postgres directory, the home directory, and I'm going to put it in the pglog archive and a folder for the main and for the replica. So I'll go ahead and create those two directories. Now I want to go ahead and configure the main cluster for replication. So again, the configuration files are in this path on Ubuntu. They may be different in your distribution. I'm going to look for the WAL level. So we want to make sure that this says at least replica. So that's good. I'm going to go ahead and turn on WAL log hints as well. This is important if you want to use PG rewind. You don't specifically need it to do it for this example, but it's something that I suggest doing if you're wanting to use PG rewind in the future. Make sure the archive mode is on. So by default it's off. Turn it on. And set the archive command. Now the archive command specifies where the WAL files are going to be archived to. And again, you'll need to remember that these will constantly be produced. So you need a way to manage them and to archive them off the system or to a different location so that they don't fill up the disk, because these will constantly be produced. So you need a way to set up to archive them. Ideally, also, if your replica is usually a different server, you may want to may have a need at some point to transfer those WAL files to that separate server. So just keep that in mind in terms of the log management portion of this. Let's look at max WAL senders. So you'll need to set up how many processes you want to be able to stream information. Now, also this can also be, these senders are also used for backups. So you also want to take into account any backups that you're going to be conducting as well, especially if you're streaming the WAL. So you just need to keep this at a sufficiently high level. For this example, 10 is more than enough, which is set at the default. Now, I'm not going to be using replication slots in this example, so I'm going to want to increase my WAL keep segments up. This assures that the master server retains a certain amount of WAL segments so that if there's any network disconnect between the master and replica, it will keep enough of the WAL files so that the replicant can catch up once the network is back online. Otherwise, you're going to have to transfer the WAL files to the replica server before it can catch up again with streaming replication. And then lastly, make sure that hot standby is on. And that's in the standby server section. You can see by default, hot standby is on. So I'm going to go ahead and write out that file. Now next, we want to edit the hostbase access file. So this configures the master to be able to accept connections for replication purposes. So I'm going to go ahead and edit this location. I'm going to put this configuration right here above so it uses it first before these other replication settings. So you can set up replication settings a number of different ways. The example I'm using, you shouldn't use in production, definitely, because it's local and it's trusted. So ideally, you're going to want to set up password-based authentication, ideally using host SSL. However, in this example, I'm just going to do set up a user called rep user and trust authentication, so that don't have to worry about passwords in this particular example. But it's not in the scope of this tutorial to show how to set up your host-based access file for a multi-server setup, but you'll have to look into how to do that. Okay, so that's been set. And now we want to go ahead and create that rep user that we referenced, and also give him the replication role. Aha, that user already exists. However, in your system, that user probably won't exist. Okay, now we want to restart the main cluster. Okay, that's been restarted. Now we want to do essentially the same thing with the replica cluster that we created. Now that is stopped, we confirm that, but if not, you're going to want to make sure that you stop this replica if you haven't already. Now I'm just going to run through configuration. The configuration is identical between them for both the PostgreSQL and the host-based access file. So I'm going to do that off camera and I'll be right back. Okay, we are back. The next step is we want to remove all the replicas database files, because essentially we're starting with a clean directory that we're going to restore the database and stream all the changes from the master to be able to replicate the data fresh. Now, when the cluster was created at the very start, this new replica cluster, it did create an initial database cluster. So we're going to need to clean out those files there. So I'm going to become the Postgres user using this command, and we're going to remove all the files in the replica cluster directory. Now, before you run this command, make sure that you're targeting the correct directory or that you're on the correct server, because otherwise this will blow away your entire database. So be very careful. Okay, so that has been removed, and now we can run a PG-based backup, because again, it's going to back up all the files and stream the wall changes to get ready to start syncing up the data. Now, if you're using version 9, you should add this command to stream the WAL files as the base backup is happening, because it'll allow you to become in sync with the master sooner. However, version 10, this is already the default, so you don't need to use this. /r gives you an initial recovery.conf file. However, we're going to specify ours down here, so we don't need to include that switch, but you're welcome to if you find it easier. I'm asking for progress, so it's going to give me a progress report of how things are progressing during the backup procedure, as well as I'm telling it to ignore a password. Now, ideally, you're going to be, if this is say a 2-server setup, you're going to be connecting across the network using a password, so you're not going to use the switch. But for this tutorial, and since I'm on a local system where both clusters are on the same system, I'm adding this W switch. U means user, and D means the directory into which this backup is going to be placing the files. All right, so let's go ahead and run this base backup. Okay, so it backed up very quickly, gave us a little bit of a progress. And now we want to go ahead and set up our recovery.conf file in the directory that we created. So you'll see a restore command that we have used in a previous tutorial, where it's basically telling us where to find the archive log files for the replica cluster. In addition, we're specifying some other configuration settings. So first is recovery target timeline. So we're specifying the latest. That means if the replica switches to different log timelines, it's going to keep on following whatever the latest one is. So if you promote a master or promote a replica to a new master, there's a timeline switch on the WAL files. So other replicas that start following that as the master, it's going to automatically change to that new timeline and keep in sync with the new master. So usually you're going to want to do this. The next option is standby mode, which means allow read-only connections and allows you to do selects on the replica database. The primary connection info is a string that you can use to connect to your master server. So there's a configuration settings that specify the user, a password file if it exists, which host you're connecting to, the port it's on, some SSL settings. And lastly, there's the archive cleanup command. Again, you don't need this, but I found it useful because it helps when you're running a replica, it helps keep the pglog archive directory clean while the replica is running. It archives any WAL files that appear there that have already been applied. Because ideally, you're archiving them from the master. However, your setup may be different and maybe you don't want this command. But let's go ahead and create this file. Okay, now we can go ahead and start up the replica cluster. It's been started. We can verify. Okay, so we can see that this is the log from the replica, consistent recovery state reach, database systems ready to accept read-only connections, and it started streaming the WAL from primary at that timeline. So we are now in sync with the master. Okay, now that the replica is in sync, let's go ahead and create a database and create a table and insert some data into it on the master server. Okay, we created the database, inserted some data. Now let's see if the data has been replicated. So we're going to connect using PSQL. We're going to connect up to the test database we just created, and we're going to select all the columns from the post table, and we're specifying the clusters the replica clusters port. And we can see all the data is there. Okay, let's simulate a failure by stopping the main cluster. And I'm actually going to look at the log files of the replica. And you can see that it's complaining because it could not connect to the primary server because it stopped. So let's promote the replica using this command. Again, this is a Ubuntu specific, but there are other distributions. I know you can use PG_CTL to do it, but I'm going to go ahead and do the promotion. We can look at the logs again, and we can see that it received the promote request here, and that it's going to select a new WAL timeline because it's a new server. Archive recovery complete, and database system is ready to accept connections. So now we can try inserting some additional data. This time we're inserting it on the replica. Because it's no longer in a read-only state, it will accept those two inserts, and now when we query it, we'll see, okay, it now has 4 rows, so it has become the new master. All right, that's how you set up PostgreSQL streaming replication. Now we just set up a single replica. You can set up as many as you would like, as long as you adjust configuration settings so that the master can handle the load, things like having enough wall senders, processes, etc. Please let me know if you have any questions. I hope that was helpful. If you want the commands used in this tutorial, be sure to visit the link in the description below. If you want to receive additional content and tutorials, please visit scalingpostgres.com. Thanks.